Good afternoon. In this tutorial, we shall discuss three things. Four specification criteria on the basis of which we shall discuss how to decide that which independent variable should be included in the regression equation. Then in the second step, we shall discuss how the Ramsey regression specification error test works, what are its equation, what are its null hypothesis and alternative hypothesis, how is this test run in EViews, and how the results of Ramsey regression specification error tests are interpreted. And in the end, we shall discuss about different functional form of the regression equation. If you need data in the soft copy, please subscribe the channel and enter your email ID in the comment section. You will be provided with the soft form of data free of cost. We are starting with the same example where our dependent variable is chicken consumption. Our first independent variable is price of chicken, second independent variable is price of beef, and third independent variable is disposable income. So in the we have to basically uh, pass each independent variable through four tests. So let's go through what those four tests are. For example, if we drop this price of beef variable from this equation, we'll call it that this is omitted variable case and specification error comes. And if we include an irrelevant variable like interest rate or like number of cars in the parking, which don't have any theoretical justification, and we include them in the regression equation, that will be known as irrelevant variable case as discussed in the previous tutorial. So let's start from four specification criteria. Now, number one criteria is theory. So we have to answer this question: is variables place in the equation theoretically sound or is ambiguous? For example, if we are confused that whether should we include interest rate variable in this regression equation of chicken consumption or not, first of all we should know and think that whether the chicken consumption depends upon the interest rate or not. That is, if it has a theoretical justification, then we can include it and say that this test is passed, otherwise no. For example, if we apply this theory test of price of beef, and it theoretically it is very sound because chicken consumption also depends upon the price of beef. Second test is t test. You know that t value is equal to coefficient divided by standard error as a rule of thumb. If t statistic is bigger than 2, we conclude that coefficient is significant. So we'll see that whether the coefficient of that variable is significant or insignificant. Then the third specification criteria is adjusted R square. We'll see that does adjusted R square increase after inclusion of said variable in the regression equation or not. And then the last and fourth criteria is bias, where we'll see that when that new variable, let's say it is price of beef, that is included in the equation, what happens to the coefficient of already included variable. If we include PB into the equation, what happens to the beta 1 and then beta 2, which be beta should have been beta 3? What happens to the coefficient of included variables? Now, next slide is about working of Ramsey regression specification error test. And this let's go to the EViews now, and we'll see here that uh, here we have our data for dependent variable y, which is chicken consumption. First independent variable is PC, price of chicken. Second independent variable is price of beef, and the third independent variable is disposable income. So now what we will do here, we believe that theoretically the equation should include all the three variables. So let's run all We'll run the regression equation with all the three variables y space c space pc, pp, and yd. So this is our original equation. Now we will drop one variable. Let's say we drop pb and we will re-estimate the equation here. Uh, if we drop here pb, then and click OK. So this is our new equation in which we don't have price of beef in the equation. If you want to view it in the form of representation, you can see that y is equal to 27.54. This is value of beta naught, which is intercept. Minus 0.41 is the value of coefficient of price of chicken, and 0.26 is the coefficient of disposable income. If you want to see its T statistic, etc., then you can see here. Now we'll see that whether this equation has a specification error or it does not have specification error. One approach is to compare these two equations on the basis of the T statistics and on the basis of adjusted R square. But in addition to adjusted R square, there is a formal test to investigate the specification error in a regression equation. That test is known as Ramsey regression specification error test. In short, we call it reset. Its working is here that Ramsey reset test involves three steps. In the first step, we estimate the equation, our original regression equation, in which we have two independent variable and one dependent variable. In the second step, we calculate the estimated values from the regression equation, and then we include the square of the estimated value, cube of the estimated value, and estimated value raised to power 4 on the right side of the equation. And then we compare these two equations and we'll see that whether the beta 3, beta 4, and beta 5 are jointly equal to 0 or not. So null hypothesis of Ramsey regression specification error test is that beta 3 is equal to beta 4 is equal to beta 5 is equal to 0, or in other words you can say that null hypothesis of reset is there is no specification error in the equation. Now, if we reject this null hypothesis, then we will conclude that there is specification error test. If we accept this null hypothesis, then we will conclude that there is no specification error test, because that if beta 3, beta 4, and beta 5 are equal to 0 and we accept it, then there will be no specification error test. Okay, and now let's move towards this output is already shown in the EViews. Let's go to the EViews part. Here we can see that this is our output of the equation in which we have dropped the price of beef variable. To run the Ramsey regression specification error test, click on the view, go to stability diagnostic, go to Ramsey reset test, click it, and then is asking for number of fitted terms. You can click post here 2 or 3. I am putting here 3. Okay. Now if we run this regression equation, you know that null hypothesis is rejected when the p-value is lower than the level of significance. Generally, we have 0.05 as the level of significance. Our p-value is lower than 0.05, so we will reject the null hypothesis. And if we reject the null hypothesis, it means that we are concluding that there is specification error in this equation. So, and then in the end, we will be discussing about the functional form of the equations. Different functional forms can be run, and about functional form, let's move towards next page, which is 232, probably 232. Yes. Now, Let me tell you once again that first assumption of the classical linear regression model was model should be linear, correctly specified, and should have additive error term. So far, we have discussed that by correct specification, we mean that all relevant variables should be included in the equation and no irrelevant variable should be there in the equation. We can try various specification of the equation by adding or deleting different variables, and then we can compare them with the help of adjusted R square. However, a formal and frequently used test to investigate the presence of specification error in the regression equation is a reset test, which tells us empirically and that whether our equation is suffering from a specification issue or it is free from specification error. The second part of the first assumption of classical linear regression model is that model should be linear. So linear equation is written like this: yi is equal to beta naught plus beta 1 into x1 plus error term. Here the interpretation of beta 1 will be slope of y with respect to x. In simple words, we will call that beta 1 will tell us by how many units dependent variable change if there is one unit change in x. Second possible functional form of regression equation could be double log. By double log, we mean that we measure the dependent variable in natural log and we also measure the independent variable in natural log form. Here, the interpretation of beta 1 will become different. Here, beta 1 is not the slope of y with respect to x like in case of linear equation. Here, beta 1 will be elasticity of y with respect to x. In simple words, in double log equation form, we shall interpret beta 1 as percentage change in y due to 1% change in x. Then semi-log form may be uh, if the dependent variable is not in log form and independent variable is in log form, or dependent variable is in log form but independent variable is not in log form. Their interpretation will be that change in y related to a 1% increase in x and then the percentage change in y related to 1 unit increase in x. Then there is polynomial form, and we interpret here uh, beta 1 will be interpreted like roughly the slope of y with respect to x for small x. So its interpretation is just like the linear equation, we just add one word for small x because as the value of x increases, the form or relationship between dv and iv remain no more linear. And then the last form is inverse form, in which we run the equation yi is equal to beta naught plus beta 1 into 1 over x1 plus error term, and we interpret roughly the inverse of the slope of y with respect to x for small x. So that's all about this tutorial, and let's go back. Thank you again. If you want to test or if you want to run the reset test and interpret it in EViews, you can subscribe this channel and you can type your email ID. You will be sent soft files in EViews format or in Excel format. And if you have any question or query, you can contact me by typing in the comment section. Thank you very much. Have a good time.